Our next speaker is David Wharton. He will be talking about SuriCata rule taxonomy, a modest teleological approach. The floor is yours.
Thank you, Josh. Hello, my name is David Wharton. I'm a senior security researcher at SecureWorks with the Counter Threat Unit, where I lead network countermeasure development. So my team is responsible for researching, writing, testing, deploying, and curating IDS rules for a variety of platforms, including SuriCata. And I'm glad I have a few minutes. I usually run out of time, so if that happens, I'll be around later, so come ask me questions. Hopefully there will be some questions about this. But let's get started. But before that, anybody here, can anybody tell me what teleological means? Any philosophy majors? All right, so teleological, the root is from the Greek telos, which means end or goal or purpose, and then the suffix ology comes from the Greek logos, which means word or speech or logic. We get that word logic. So when we talk about teleology, we're talking about the study of the purpose or the study of the end goal of something. So when I talk about a teleological taxonomy for rule sets, we're talking about classifying rule sets based on what the purpose of that rule is, what it's trying to detect. And if you're familiar with Aristotle, he talks about teleology, and Aristotle has his four causes. Formal cause, the material cause, the efficient cause, and the final cause. So if Aristotle were to look at a SuriCata rule, he would say the material cause would be the corpus of the SuriCata rule syntax. You could even say, the ASCII character set. The formal cause would be the rule itself with the specific keywords and directives and the specific order in which it manifests itself. The efficient cause would be the rule writer, so myself or you as a rule writer. And then the final cause would get into the teleology of it, the purpose of the rule, why the rule was written, what it's looking for. And that's what we're going to consider here today. So the problem that I started with was, which rules should I enable? I mean, there's tens of thousands of SuriCata rules available. And the assumption is, and logic kind of dictates that you don't want to run all the rules that are out there for a number of reasons. One of them is you have a limited amount of resources on your sensor. However beefy it is, it's got finite resources. And that's compounded by certain environments. So if you're running SuriCata on a virtual machine or in a Docker container or in a Kubernetes pod, which I've run SuriCata on all those things, you may have even more tighter resource constraints. And then I know a lot of you look at high-speed networks. I talked to a few people last year at SuriCon that were inspecting or wanted to inspect 100 gigabit networks. And when you're doing that, your resource constraints are certainly in view. And then you have to consider the particular assets that are being protected. Maybe your SuriCata sensor is just looking at your web server farm, in which case you don't care about rules that are looking for browser exploits, or it's just looking at your corporate workstation environment, in which case you don't need to be running the SCADA rules. And then when it comes to alerts, you only really want relevant alerts or alerts that could be relevant. And if you run all the rules, you're going to get a lot of noise, and you're going to get a lot of false positives as well. And there's certain rules where if run in one environment, you're going to get a lot of alerts, whereas if you run in a different environment, seeing an alert from that rule is highly suspicious and worth investigating. So your rule set needs to be tuned for its environment. And finally, having a tuned rule set lets you drop with confidence. At SecureWorks, we manage thousands of sensors, and 3 out of every 4 of those sensors is running inline. And 80 to 90% of the rules in our rule set are set to drop. And so we drop a lot of packets, and we enjoy dropping a lot of packets because there's a lot of bad stuff out there. And so we probably dropped 10 tens of millions, if not hundreds of millions of packets a day with confidence and with impunity because we're not worried about breaking somebody's network. So a little bit of background and some previous work on this. There's some RFCs and some protocols that have been put out there, but these are more focused on kind of the back end. After the alert's been generated, how to classify it, and then how to exchange that information. But here, I'm more interested in the front end. What rules should I enable in the first place? And the traditional approach is to use this classification.config file and then have a corresponding class type keyword in the rule. And the classification.config file has to be externally maintained, and typically it has about 200 or 24 finite classifications, but these classifications are fairly broad and arguably nebular, and some of them talk about attack technique, some are for attack target or attack impact, some are more generic, just protocol, and so they're kind of all over the place. And you can only have one class type rule option per rule. So you have to kind of pigeonhole your rule into just one classification, and a lot of times the question is, well, which one should I use? It could go in, multiple different categories. I have to just pick the best one, whatever best is. And so the other approach is to divide your rules into different rules files and then enable or disable those rules files as a whole. But that suffers from the same problems because the rules files people use to divide up these different buckets have the same problems. Some are for attack technique, and some are for attack impact, and some are just generic. Some are just like, oh, bad.rules. It's like, okay, well, and it has the same problem where you can't have the same rule in multiple rules files and have both those rules files enabled. So if I have an exploit kit rule, should it go in exploit kit.rules? I mean, that would make sense, but what about browser IE.rules or current events.rules? I don't know. So this approach in this historical strategy of using the class type and using the different rules files, in my mind, is kind of like Santa Claus. You used to believe in it. So we need a better approach. So let me introduce the better enhanced teleological and taxonomic embedded rules standard. And yes, it's a self-referencing acronym, so it's already got that going for it. In this standard, I propose using key value pairs that are embedded into each rule, so there's no external maintenance of some other file, it lives with the rule. You can have a one-to-many relationship, so you can have the same key and multiple values for it. And in SuriCata, this is going to be implemented in the metadata keyword, which is already supported by the rule language, so there's nothing new that needs to be added to SuriCata. We're already leveraging the metadata keyword, which, if you're not familiar with it, it's a non-functional keyword, non-functional in terms of traffic detection. And as an added bonus, as of SuriCata 4.1, the metadata key value pairs are also included in the eve.log. And this is kind of a happy byproduct of this, where it wasn't my intention to enable analysts on the back end to have more information, but it does get included. So if you're analyzing an alert, you have all this rich metadata associated with the rule as well to help you make decisions. And by using these key value pairs in the metadata, they can be programmatically consumed and then utilized to slice and dice your rule set. And then the standard itself, we'll get into it, it's flexible. You can extend it to as you need for your particular environment and rule sets. And then I tried to make it simple. Some of these classification schemes get real complicated. They'll say, oh, we'll have an indicator, and then we'll add a tag to the indicator, and then we're going to add a label to the tag on the indicator, and then we're going to add a label to the tag on the label, and then we're going to add a color, and then we're going to add this invisible namespace to it, and it gets real complicated. So I try to keep it fairly simple. So just a quick, simple example of what I'm talking about. You have this metadata keyword, and then In this example, you have the key priority and the value medium, the key protocols, the value SMTP, the key protocols, the value TCP. So you can have, that one-to-many relationship here shown in the protocols key name. And then in the Eve log, it looks like this. This kind of helps represent, how this should be logically interpreted. So then the question is, what key value pairs should I include? What is useful here? And so I asked myself, all right, well, what are we trying to protect? Now, we could spend hours talking about the theory behind this and discuss data-driven security and discuss attack trees and risk matrices and all that. I'm not trying to get into that, nor am I trying to propose a thesis and defend it here. I'm just trying to share some of my thought process behind this. So what are we trying to protect? I think it comes down to data and assets. And with data, though, from a network perspective, the data has to travel through and travel to and live somewhere, which would be assets. And so then the thought is, well, if you can protect the assets, then you can succeed in your protection. But remember, we're operating from a network perspective. So when it comes to assets, continuing with the philosophical theme, I was reading the great 18th century philosopher and theologian Jonathan Edwards, who's considered by some to be the greatest mind America's ever produced. And he talks about teleology, and he speaks of ends. And he talks about inferior ends and a chief end and ultimate ends and subordinate ends. And I thought, oh, that makes sense. And so I like to think of ultimate endpoints and subordinate endpoints, where an ultimate endpoint would be traditionally what you think of with an endpoint, which would be kind of a leaf node on your network path, and then a subordinate endpoint would be an endpoint that's not valued for its own sake, but valued as a means to a further endpoint and eventually an ultimate endpoint. So this would be things like routers and switches traditionally. And in the context of network security, these endpoints can be defined by what they communicate and how they communicate, so services and protocols. And the other thing I thought of, or people told me, was, oh, what about industry vertical? Split it up, divide it up by industry vertical. But I'll be honest with you, I don't think that's useful. I mean, I never believed in that. They say the world is flat, and the industry attack surface is flat. I've worked for Fortune 500 companies in the financial industry, in the technology industry, in the transportation industry, and smaller companies. And guess what? They all run the same stuff, right? Their workstations are probably going to be some flavor of Windows. If they run web servers, it's probably going to be Apache or IIS or Nginx. If they run mail servers, it's probably going to be Exchange or Postfix or SendMail or Lotus. Now, there are some exceptions like OT, but I'm not going to get into that. So the industry vertical categorization does not exist in the standard and never will. And then the last question is that I asked myself was, well, what data do I already have? Because I didn't want to go through tens of thousands of rules and add all these metadata tags to it. And fortunately, we've been writing IDS rules for 20 years, and we have a lot of metadata already associated with each rule, and then rules are tied to vulnerabilities, and I have a lot of vulnerability information, or rules are tied to malware, and I have a lot of malware information. So I have all this rich data that I can pull from. So I wasn't completely unbiased in defining the standard when I approached it, but I went with a lot of what I already had. So to get started, the schema has some ground rules. You can read it for yourself, but the key takeaways are key names and values are case insensitive, they're printable ASCII, and the key and the value are separated by a space where the key name will be the first word and the value the subsequent part. And the pairs themselves are going to be comma separated. And in the standard, there's a need to define some key names. I didn't want a case where people were using different key names to describe the same thing. So MITRE ATT&CK versus MITRE ATT&CK without an extra A, or protection target versus attack target. Now, I talked with emerging threats starting, I guess this last summer, so for a number of months we've had some open conversations, and initially I sat down, I kind of defined the keys and the values and formats that I was thinking of, and then I looked at the emerging threats rule set and saw that they had done some stuff with metadata tags as well, and so we looked at, what's valuable, what do we want to include, and they had this attack target key name, and I was going to call it protection target because I was thinking, oh, what am I trying to protect? But anyway, they convinced me attack target was fine. So, attack target won out in that case. But, there's some others like, or you can call it priority or severity or criticality or whatever. So there's some cases where key names are defined in the standard, and then there's some cases where values need to be defined. A few cases where there's a finite set of values, like with the priority key, it's high, medium, low, info, and research. So that there's no question about, what's what. And then for some formats, there needed to be a defined format. So specifically with dates, what should it look like? Or with the CVE, should there be a leading CVE dash or not? So things like that. So we're going to go through this standard. I'm going to try to go pretty quick. The first two keys are probably the most valuable in my mind. And the first one is protocols. This is pretty self-explanatory, nothing special here, but there's no concept of different layers. There's no segregation of, oh, this is transport layer and this is network layer. It's just if the rule is attempting to inspect a particular protocol, then include a key value pair for that protocol. I don't include IP. That's kind of assumed that this is going to be over IP, unless there's some cases where the rule is specifically looking for IP. So alert IP rules, I'll stick it in there, but pretty much layer 4 and up. And then with TLS and SSL, I don't bifurcate TLS and SSL. It's just all TLS. And then attack target is the other key. And this defines what type asset is protected by this rule. So the way I went about it in our rule sets is I enumerated all the protocols, and then I looked at the rule, I looked at the flow, I looked at what's home net, I looked at what end is hostile or infected, and then I made a determination where it's protocol-server or protocol-client in terms of what I'm trying to protect here. I also added one called database server that, there's no database protocol, but, people run databases, and so I can make some assumptions from my rule and some determinations and also label it like that. Now, the thing with, I may not have made this clear with the better standard, these are just example values. You can do whatever you want for your rule set, as long as you're consistent. I encourage you to be consistent, otherwise it won't have value. But this is kind of how I did it. But the attack target, it's intended to define what asset is protected by the rule. So if you're running a web server farm, you can just say, okay, I want all the HTTP server rules and all the TLS server rules. So going through some more MITRE attack key with the MITRE attack framework ID as the value. This, everyone gets, just super excited about MITRE attack, especially managers and executives. And so, if you want to get funding for something, just say, oh, this is for MITRE attack. So that's how this research got funded. I'm just kidding, mostly. So the MITRE attack key, somebody was mentioning in a talk earlier, oh, I wish that there was MITRE attack classification in the rule. Well, guess what? Here it is. But, MITRE attack's fairly new, and before MITRE attack, MITRE had CAPAC and CWE. CAPAC is common attack patterns and exploit classification, and CWE is common weakness enumeration. And for years and years, we have classified each and every one of our rules according to a CAPAC ID, and vulnerabilities is according to CWE IDs. So we have all that data, and that gets included in the metadata. There's also the malware key. This is not intended to define or identify specific malware behaviors. It's more generic. It's just saying this rule is intended to identify malware traffic. And the values I use are post-infection, pre-infections to kind of differentiate the kind of traffic that this rule is trying to detect, so that I know, oh, these post-infection malware rules, okay, this is detecting an infected asset, and I can be informed of that. Then there's the Cve key. This is pretty self-explanatory. The format does not include the leading Cve dash, and it has a dash between the year and the sequence number. CVS V2 and V3, base and temporal scores, may or may not be valuable for you. I know it's valuable for some people, so it's included in here. There's no differentiation between CVSS V3 and 3.1, it's just V3. Priority, high, medium, low info research. And this is intended to standardize the priority or severity, because some vendors will call it priority and some will call it severity. I've worked on products where severity 5 was considered high and priority 1 was considered high, and you got some vendors like Drupal that's, has like high and critical and highly critical and super secret double critical, and it's like, well, what does critical even mean anymore? So this is intended to take the confusion out of that. So high, medium, low info research, we kind of understand what that means. And so whatever classification you might use in your space, that can be mapped to these 5 values. And we can all agree on the standard. And then created at and updated at, emerging threats, has these on their rules, and so I borrowed from them. These are pretty self-explanatory. The format is ISO 8601, which makes sense. So year, 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 dash, month, month, dash, day, day. And then the hostile and infected keywords. Strictly speaking, these are not teleological, but they're valuable enough that I included them. The hostile key defines which side of the alert is considered hostile, and the values can be source IP or dest IP. Now this is the inverse of the target SuriCata keyword. If you're familiar with Eric LeBlanc's target keyword, I don't know if anybody's really adopted that fully, but it's kind of the inverse of that. And then similarly, the infected key, it defines which side of the alert is the malware infected host. And these really come in handy on the back end where an analyst is looking at the alert and he doesn't have to guess which side is the infected side, or excuse me, or if you have a orchestration implemented or a SOAR pipeline where you can take in this information. You've got this high priority malware related rule alert, and it says, okay, this side is infected. Well, you can go ahead and combine that with other data if you want, and then make a decision, okay, we're going to go ahead and isolate this host. Or if you have this alert and it's somebody's scanning you or trying to exploit you, and the alert comes in, you can say, okay, this is the side that's hostile, this is external to us, we're going to go ahead and firewall it automatically with our orchestration pipeline. So it really does come in handy, I think. And then the file name and the class type keys, if you still believe. These would be, so for file name, this would be, if you had split your rules into different files, this would be the file name of the rule, and class type is the same as the class type keyword, except you can have the one-to-many relationship here, so you don't have to just pick one. You can add multiple class types to your rule metadata if you want. And then finally, there's rule source. So this would be the vendor or the person or whoever's responsible for this rule. And this really comes in handy because, SecureWorks, we have a rule set and it's got all these metadata keys and values, and we may do something one way with, let's say, attack target, and another vendor like Emergent Threats may do it another way. And so when you're filtering your rule set based on these keys, you might want to define different rules for SecureWorks versus Emerging Threats. Well, if you have this rule source in there, it's real easy to say, okay, all the SecureWorks rules we're going to treat like this, and all the Emerging Threats rules we're going to treat like this. And so this rule source key is necessary to distinguish those. And then finally, your own key. I mean, this standard isn't definitive in terms of these are the only keys that can be included. You can add whatever you want, as long as it follows the basic ground rules in terms of keys and values. The only thing is, if you want to be useful, you need some type of consistency in the way you do it. So looking at a more fuller example would kind of look like this in a rule with this metadata key and then all these key value pairs in there. And the ev output snippet looks like this. So now that you're familiar with the better standard, you're probably all asking yourselves, where can I get better rules? Well, it's, this is new. I'm talking about it for the first time in public here today, so it may take a little time for vendors to adopt this, but I would encourage you to encourage your vendor. In the United States, we say write your congressman, but, I guess email your congressman now, or, talk to your vendor and say, hey, we heard about this better standard and we think it's really valuable. SecureWorks, obviously, I went through and wrote some code to add all these metadata keys to our rules. So we have an enhanced rule set that we sell. It's fully compliant with the standard, and it has holistic coverage, which means all the rules have all applicable key value pairs that I talked about, plus some. The only exception is MITRE ATT&CK. We don't have the MITRE ATT&CK classification on all the rules yet, but that's coming. Emerging threats, I've been talking with them. They're mostly compliant. Technically, there's a few issues where they use underscores instead of dashes. They would also benefit from better coverage. In some cases, they use a key and it's great, but it's only on a few hundred rules. But they're working on it. They're considering it at least, and I would encourage you to encourage them to adopt this. I know somebody, I think I said earlier, was saying, oh, I wish we had MITRE ATT&CK in there, or there's some other use cases where it'd be very useful. So we've got the standard, we've got the rule set with the metadata key value pairs. Well, now, how do you take advantage of that? So I take the next step, and I wrote a piece of software called Aristotle, which does rule set filtering based on metadata key value pairs. And it's just a Python script, supports Python 2.7 and 3.0. It's just a few hundred lines of code. It's nothing real complicated. You can run it as a standalone script, or you can load it as a library or module. It's in PyPy. You can just pip install Aristotle. So if you had some type of tool that did like SuriCata updating of rules, then you can incorporate that into your product. And it's open source. The code's on GitHub, and the docs are on Read the Docs. And it uses Boolean logic to where it takes the metadata key value pairs as values in a concrete Boolean algebra. So you can define what I call a filter string to slice and dice your rule set based on this metadata key value pairs. And the inputs are going to be a rule set, obviously, and then a Boolean filter string. And the outputs, it can just output the metadata statistics if you want, or it can actually output the rule set itself filtered per the Boolean algebra. It doesn't modify rules, it just turns them on and off. And then before you ask, is there SuriCata update support? And the short answer is yes. It's not in the master branch yet. I wrote the code on the plane over here yesterday, and there's a pull request. I think I submitted it to the wrong branch, but yeah, there will be SuriCata update support, and certainly feasibility has already been demonstrated. So a quick screenshot. Here I'm just pulling statistics about the keys. In the GitHub repository, there's an example.rules file that has a few thousand example rules that have these rich metadata key value pairs populated. Now, I shouldn't have to say this, but it's not a real rule set. I mean, it works, it's syntactically correct, and it'll load, but it's not a real rule set. You don't want to run it on a production environment. So here we're just showing some stats about, okay, here are the key names that are in the rule set. If you want details about particular keys, you can ask for the stats. Here we've got asking for stats for the malware key and the priority key, and we get details about that. And then the Boolean filter string, it uses Boolean logic, so and, no, or, not. You do grouping with parentheses. You can, if you want to match all the values of a key, you can use this all keyword, all in angle brackets. And then there's certain key names that support greater than and less than and greater than equal to and less than equal to. So things like SID and CVE and CVSS and created at and updated at, you can give it a date and say, oh, I want all rules that are created, after this date or between this date range or whatever. So for example, created at greater than or equal to, January 1st, 2019. So just a simple example, if you want to match all high priority malware related rules, you would do something like this. Or if you want to match all high priority rules that were created in 2019 or involve a vulnerability based on CVE number from 2018 or later, you would do something like this. Or if you want to match all high and medium rules that are designed to protect a web server, you could do it like this. So you can pass Aristotle you can give it the string on the command line, or you can just give it a file that has the string in there, and it'll read it. And then in this case, it outputted the first 16 and of 315 rules, and then wrote those rules out to a file. So, and that's it. Thank you.
If anyone has any questions, I will come to you with the microphone.
Oh, no.
I'm not sure it's on. Yep.
Thank you. So I really like it, so thank you. I was wondering about a couple of sort of overlaps between a metadata keyword and an actual rule keyword. Like we have a prio keyword or priority, and then it also exists in the metadata field in this standard. So should Suricata somehow interpret the metadata or completely ignore it, or should it try to validate it? Or
that's a good question. They're separate. For Suricata, there's a one-to-one mapping where really in my mind, priority 1 is high and priority 5 is research. But the standard itself isn't Suricata specific, so it can apply to snort rules, or it can apply to rules from another vendor if they have a similar way to communicate key value pairs. So that's why we have the priority key word where different products may have different levels for different things, and so it's standardized. In the case of Suricata, it is kind of an overlap. There's also the SID keyword, which you shouldn't have a SID metadata key. It's redundant. But things like Aristotle will actually read in the SID and create a kind of a pseudo key value pair with the SID and the SID value, so that you can then use that for filtering if you want to exclude specific SIDs or include specific SIDs or ranges and things like that. Does that answer your question?
yeah, I think so. I guess, would you feel that Suricata would have to sort of validate that these fields are not conflicting?
No, I think you can keep your Suricata priority and leverage it however you want, but in terms of defining your rules and then filtering them according to the metadata key value pairs, you've got high, medium, low info and research to deal with, and so you map your rule priority level to that, and then you can filter on that just using those metadata key value pairs. And if you want to instrument your SIM to respond to the metadata versus the priority key value, then that's up to you.
I guess this is more of an answer than a question, but just one thing to mention, tomorrow I'll be giving a lightning round talk on the ET roadmap, and we'll be talking about metadata tags. They'll play a big role. So before everyone swarms me at the reception, I figured I'd mention it.
Hopefully it's better.
You mentioned you are not taking into account OT, but there's a lot of IoT devices and specific protocols. How do you plan to address that?
So I didn't take into account OT when I was talking about talking about vertical classification. But if you want to take the OT protocols and the ICS protocols, then I would put that in the priorities, or excuse me, in the protocols key. So you could have things like protocols, SCADA, protocols, Modbus, and do it like that. Does that make sense?
Just thank you for your talk and thank you for the work, Eric here. So that's a great job. I've got a few questions. What do you do if you have two metadata with the same key? We have seen that.
You mean the same key name but different values?
Yes.
Well, I mean, that's intentional. So you're supposed to be able to have that one-to-many relationship. So protocols TCP, protocols SMTP. So you have all those. So those are both included in that list of protocols.
Okay, so in the output, we should switch to list in this case.
Yeah, it's a list. So the SuriCata Eve log interprets it as a list anyway. And so if you go back to, oh gosh. Okay. If you look at the Eve output, it's somewhere in here. I mean, this is how it's logically interpreted by SuriCata, but also by anybody that wants to interpret it. So in the protocols key, you have this list, TCP and SMTP. Attack target, you have SMTP server, and you have server. And so really all this is populated, and then in your Boolean algebra, you define what you want.
Okay, second question. You mentioned the non-equivalent, but the opposite of the target keyword. And you said in the slide that it should be explicitly limited to source and destination IP. What about an alert on SMTP, where the really interesting part is the RCPT2?
I'm not sure I heard all the question.
So if you have an alert on SMTP, like a phishing attempt on SMTP, you don't really care about the destination address or source address because it's the SMTP server. What really matters is the recipient of the mail. So why not being able to put some other keys inside the hostile or victim ID? Problem is the normalization of the value.
Yeah, I mean, a phishing email, there wouldn't necessarily be an attack target in that case, right? The attack target is really the end user there, but your mail server is not being targeted. Even your email client isn't necessarily being targeted. You could make that argument, but you may not have a specific, protection target or attack target value in that case. Does that answer your question, or does that address the question you're asking?
Yes,
Phishing can be kind of a tough one.
All right. Any more questions? Okay, great.
All right, thank you guys.